Assalamu alaikum. We are gonna present in the slides for Doppler blood flow meter, the group 5, Faiha, Ahmed, and Mohammed. This is the content of the slides. This is the introduction. Uh, what is Doppler blood flow meter? A non-invasive diagnostic device used to measure the velocity of blood flow through the body's vessels. Principle of operation utilizes the Doppler effect, where the frequency of ultrasonic waves change when reflected off moving objects such as red blood cell. Significance in medicine essential for diagnosing conditions like blood clots. Applications commonly used in cardiology, obstetrics, and vascular surgery to monitor blood flow characteristics. Okay, for the master oscillator, definition, the master oscillator is responsible for generating the primary ultrasonic frequency used in the flow meter. The importance of the master oscillator ensures the stability and accuracy of the ultrasonic wave that interact with blood cells to measure flow velocity. The technical insight, the frequency generated determines the sensitivity and the range of the Doppler shift that can be detected. Uh, Here, the power amplifier. The key features discuss the technology used to ensure consistent amplification, such as feedback mechanism or automatic gain control. The purpose amplifies the ultrasonic signals to sufficient levels to penetrate bodily tissues and return measurable echoes. The challenges for the power amplifier must amplify without distorting the signal, maintaining signal integrity for accurate diagnosis. So, and for the transmitter element function, the function of the transmitter element converts the electrical signal from the amplified oscillator output into ultrasonic waves. The material used typically involves piezoelectric crystals that are effective at these conversions. Significance, placement, and quality of the transmitter are crucial for optimizing the interaction with blood flow and ensuring accurate flow measurement.
A range-gated Doppler blood flow meter uses signal processing techniques to extract information about blood velocity from the received ultrasonic echoes. In the initial state, from the receiver, we have receiver elements, receiver limiter, phase detector, and low-pass filter on the first stage. Here's how the initial stages contribute to this process. The first one is the receiver element. A receiver element acts as a transducer, converting the electrical signal from the instrument into ultrasonic sound wave for transmissions and vice versa. In blood flow meter, it receives the returning echoes of the transmitted sound wave after they interact with blood cells. Second is a receiver limiter. So the function of a receiver limiter is it limits the dynamic range peak-to-peak amplitude of the received echo signals. In blood flow meter, it prevents strong echoes from saturating the circuit and ensures a consistent signal level for further processing. This is crucial because the phase detector relies on the relative phases of the signal. Third is phase detector. The function of phase detector is it makes the received echo signal with a reference signal derived from the original transmitted pulse. In blood flow meter, it creates an intermediate frequency IF signal. The key aspect is that the phase difference between the mixed signals carries information about the Doppler shift caused by moving blood cells. Doppler shift is the change in frequency of the sound wave due to the relative motion between the sound sources and the reflecting object. The last one in this initial process is low pass filter. So the function of low pass filter is to remove unwanted high-frequency component from the IF signals. So in blood flow meter, it eliminates noise and harmonics introduced during transmission, reception, or within the electronics. These high-frequency components can interfere with the Doppler information encoded in the phase variation of the IF signal. The filter allows only the relevant lower frequencies to pass through, preserving the Doppler information. This initial processing chain prepares the signal for further analysis. The subsequent stages typically involve demodulation, which is recovering the Doppler shift information from the phase variation of the filter signal. Second, gating, which is selecting echoes from specific depth within the vessel using a gating window. This allows focusing on blood flow at a particular location and eliminates unwanted signal from other tissues. Last, signal processing. It calculating blood velocity based on the Doppler shift and potentially additional processing to account for probe angle and other factors. By processing the received signal through these stages, the range-gated Doppler blood flow meter can extract valuable information about blood flow velocity within selected region of interest.
Next up, we have the pulse amplifier block, which amplifies the weak Doppler signals received from the blood flow. The Doppler signals, which are produced by the reflection of the ultrasound waves off of moving red blood cells, are typically very weak and require amplification to be processed further. The pulse amplifier ensures that the signal is strong enough to be analyzed accurately. After that, the frequency division block is used to process the Doppler signal by separating the high frequency ultrasound carrier wave from the lower frequency Doppler shift signal. This is achieved through electronic circuits that divide the frequency of the received signal. The resulting signal corresponds to the actual blood flow velocity, which is then used for further analysis. Next is the sample pulse generator and the sample and amplifier blocks. The sample pulse generator block creates timing pulses that control when the Doppler signal is sampled. This is crucial for converting the continuous Doppler signal into discrete samples that can be processed digitally. And the sample and amplifiers block then takes these discrete samples and amplifies them for further digital processing. This step is essential for accurate digitization and analysis of the Doppler signal. Lastly is the second stage of the low-pass filter and the audible output. The low-pass filter, or the second stage of the low-pass filter specifically, is used to remove high-frequency noise from the amplified Doppler signal, leaving only the desired frequency components that correspond to blood flow. This filtered signal is then converted into an audible output, which can be heard through speakers or headphones. The audible output allows clinicians to listen to the blood flow, providing an additional method to assess blood flow characteristics in real time. So finally, in conclusion, Doppler blood flow meters are important biomedical devices that are crucial for the measurement of blood flow characteristics in a precise manner with the use of ultrasound wave characteristic interactions with blood flow. This presentation has gone over the working mechanism of the Doppler blood flow meters in general, as well as the various intricacies and details for its proper functionality for each of its most important circuit blocks. Thank you.